Hi, good afternoon. We're here to talk about the Module 7 Review Part 2. So if we look at this is if you go to your Teams page in the Files tab, this is going to be uploaded there. Okay, the first section, they want you to give the exact value, and there's a hint that use your unit circle. So first off, they want the cosine of 7 pi over 6 radians. So they're inputting an angle, they want you to give them the ratio. So if you think about your unit circle, 7 pi over 6, that's 210 degrees, and the cosine is going to relate to the x coordinate, so it's going to be minus radical 3 over 2. So now the next one, number 2, they want the inverse sine of negative 1/2. So here they're giving you the ratio, and they want you to tell them the angle. Since it's a unit circle, you'd think they might want the angle in radians, but radians or degrees would be fine. So sine is going to be the y coordinate. So you're looking for a y coordinate of negative 1/2. So if you get back here, y coordinate, well, there's a y coordinate of negative 1/2. That's at 4 pi over 3, which is equal to 240 degrees. But you might say to yourself, that's not the only, that's the x coordinate. So we're going to just scribble that up. Luckily enough, we're writing in pen. So now, don't do what I did. Sine. You want the y coordinate. Not the aforementioned x coordinate. So what that really wanted to be was 7 pi over 6, which is the same thing as 210 degrees. Now, y coordinate is negative here at 210 degrees. Well, the y coordinate is also negative if we go from 210 across the road to 330. We have a negative y coordinate also. So there's going to be two answers here. Or this is 11 pi over 6, which is the same thing as 330 degrees. Whew, dodged a bullet on that one. Okay, now sine. They're back there. They give you the angle, and the sine is going to be the y coordinate. Remember, sine, y, cosine x. Apparently I have to say that to myself several times too. So sine of pi over 2. So we're looking for pi over 2. That's 90 degrees. So you look at the coordinates at 90 degrees, or pi over 2, and we wanted sine, so we need the y coordinate, so that's 1. Oops, see if I can get that together. So 90 degrees, that's going to be a 1. Now, number 4, the inverse cosine of radical 3 over 2. Cosine being x, so this is the x coordinate. Radical 3 over 2 is the x coordinate. We want the angle that shows up there, and it's a positive. So, matter of fact, there's a y coordinate, but I said x coordinate, didn't I? So I need an x coordinate that's radical 3 over 2. Cosine is x. So, that's negative radical 3 over 2. Well, there's radical 3 over 2 for the x coordinate right there at 30 degrees. Now 30 degrees is pi over 6 radians. So that's our first answer. Let's go over here. So the inverse cosine of radical 3 over 2 is going to be 30 degrees, or if you want to say it in radians, you can say pi over 6 radians. Now, that's not the only place where you have an x coordinate that's a positive radical 3 over 2. If we went straight down there at 330 degrees, we have a positive radical 3 over 2, and that's 11 pi over 6. So number 5, tangent. Now, if you're using unit circle, tangent of pi, you probably could just do this on your calculator also. But just remember, tangent is a sine of pi over a cosine of pi. So there's pi on the unit circle. Sorry, I have to be so zoomed in here. So it's the sine is the y coordinate, cosine is the x coordinate. So the y coordinate is 0, the x coordinate is -1. Remember, when 0 is upstairs, it's just plain old 0. Okay. So now we're getting all funny here. We want the sine of the inverse cosine of 0. So you got to start on the inside first. So they've given you the cosine, they've given you the ratio, it's 0. They want the angle back. So what's the angle when your cosine is 0? Well, cosine is the x coordinate. So for the x coordinate, we actually have two x coordinates that are going to be 0 at 180 degrees, well, pi, or at 0. So, and if you wanted to call that 2 pi, you could call it pi or 2 pi. So you have 2. So we found, let's just call it 2 pi. So now we need the sine of pi. So now we'd have to go to pi. The sine is going to be the y coordinate, which is, oh my god, I did it again, didn't I? Oh my goodness, I just made too many mistakes on this one. So cosine is the x, so it would only be 2 pi. Notice I was looking here, but I saw that's obviously a y, and I saw that as an x. Don't do what I do. In my defense, it's kind of late at night for me. So I am making silly errors. So be kind of careful. Always check on your stuff. Say, hey, does this make sense? So when I do the inverse cosine of 0, I need an x that is 0. My goodness. So the x is 0 at 90 degrees, and the x is 0 at 206. X is 0 at 270 degrees. So then that would mean, so we'll just say we need the sine of 90 degrees, and we need the sine of 270 degrees. Sorry about that. So if we go to 90 degrees, and the sine is the y coordinate is 1. So we go to 90 degrees, we want the sine of 90 degrees. So sine is the y coordinate, we need the 1. So at 270 degrees, we need the sine, it's this or this one. So we need the y coordinate at 270 degrees, which is -1. Whew. Made a couple of boo-boos on that one, didn't I? So I hope this is in focus. It continually looks like it's not in focus to me. All right. So number 7. We have y equals 4 cosine pi over 2 times x plus pi over 8 plus 5. So A is for amplitude. The amplitude is the 4. Amplitude is the first number. Now, the period equals 2 pi divided by b. Well, that's 2 pi. RB is the, remember, this guy is the A, this guy is the B. So B is pi over 2. So we got ourselves a nice compound fraction here. So let's call this 2 pi over 1. We're going to change from divide to multiply, and then we're going to flip the second fraction. So our pi's are going to cancel. 2 times 2 is 4. So the period is 4. Now the phase shift is the C right there. So that's plus 8 pi, pi over 8, pi over 8. And then that's a plus, so that's actually going left. Remember, phase shift is the one that is opposite guy. So normally you think a plus goes to the right, but he's opposite guy, so it's pi over 8 to the left. And then the vertical shift is the D. It's the last one, and that's just going to be 5. Pretty easy, huh? So let's play the little game. Last question we're going to do in this video. What quadrant is it in? Now, they're giving you sine as 0.9108. I don't actually care about the number, other than if it was 0 or 1. Okay, all I need is sine is a positive number here. So this is sine of theta. Sine is going to be the y coordinate. So basically, on my unit circle, I need a y coordinate that's positive. So the y coordinates are positive when you go up. So that's in quadrant 1 and quadrant 2. So first one, quadrant 1 or quadrant 2. Now the second one, cosine of theta is negative 0.6217, and I'm more care that that's just a negative number. So cosine of the x, so I need x values on the unit circle that are negative, like this one and that one here. So this is, it's quadrant 1, 2, 3, 4, and the x's are going to be negative in quadrant 3 and quadrant 4. Quadrant 1, 2. Okay, I'm going to have to say this right. This is like the 4th mistake I've made in one video. I'm having a tough time this evening. So that's quadrant 2, that's quadrant 3. Now there was one last one happened to be, I kind of goofed it on mine. They wanted the tangent of 18.137. So let's just see. It's supposed to be the tangent. 18.137. Now one more time. Tangent is going to be the sine divided by the cosine. Okay, and I really only care that that's going to be a plus number. So if you do in quadrant 1, if you do the y divided by the x, that's a positive divided by the positive. So you know one of your answers is quadrant 1. And then in quadrant 3, you have the y divided by the x. A negative divided by a negative is a positive. So this one is quadrant 1 or quadrant 3. Alrighty. Hope you found that enjoyable. I will be on in another video for the rest of this.